We're really happy to be here today and talk about a really important subject that I know that everybody's been dealing with the last couple of years. And we're going to talk about the transition from physical networks to virtual networks. But first thing I thought I would tell you a little bit about our company, which I think you should know about. The company is based in Germany. We're about an hour outside of Frankfurt. We have development all around the world and sales around the world in the U.S., UK, Italy, Ukraine, India, Singapore, Malaysia, and Australia. The thing to think about our company, it's important that our DNA is really in software development and OSS, automation, network management, broadcast, content networks, and CSPs. And if you talk about broadcast software, if you are a NASCAR fan, if you're an NFL fan, or a World Cup fan, our software has been used to provision those broadcast services all around the world. So if you're a fan of any of those sporting events, well, we've been a part of that in the background. Our software, it's like I was saying, as far as the broadcast portion of it and also on the OpsNGN that we're going to be talking about in a few minutes here, is deployed in mission-critical real-time scenarios. And we believe the number is about 600 million end users, especially on the broadcast side. We have customers worldwide, including North American Tier 1 customers, and soon to be, hopefully, other Tier 1 customers in Europe and in Asia-Pac. Again, getting back to our DNA, I mean, the company's really built on a few different things, but our mission critical is really to provide the highest degree of automation and remove the complexity from all our users. I want to talk to you about a new product for us. A product is called OpsNGN. Kai and I will go into this a little bit, lightly. Obviously, we don't make this a sales presentation, but going to our subject, going from transition from physical networks to virtual networks, I want to let you know what our involvement kind of looks like today. So if you look at this diagram, it's a new product for us. It's called OpsNGN. It's an OSS Automation and Orchestration platform for physical networks for today and SDN and NFV networks of tomorrow. It's a multi-layer, multi-technology, and multi-network vendor networks like IP, MPLS, optical, video solution. And if you look at kind of the diagram here, OpsNGN has the unique ability to completely orchestrate applications and network services. As we all know, in a really hot subject that has been talked about for many, many years, if you think about everything that's being done with MEF and other organizations, is really talking about lifecycle orchestration, or LSO. And LSO is really important for insurance, protecting your existing environment, and helping bridge the gap between physical and virtual networks. So if you can see, we're kind of at the heart of it with our OpsNGN platform. If we take a little bit of a deeper dive into this, you could take a look at, in the middle, at the very core of any digital transformation, is having the integrity and accuracy in the inventory and the topology. So you can see kind of the heart in the red is our dynamic inventory. The dynamic inventory has the ability in near real-time inventory and active topology for physical networks, if you take a look at the left portion of the slide, and also for virtual networks. In our discussions with CSPs, and I've been in the industry, longer than I want to admit to, over the last 30 years, that many CSPs, their inventory, they tell us their accuracy is between 50 and 80%. If you really think about that number, that's pretty low, especially if they're on the 50% side, that they're not really getting a totally accurate picture of what's going on their network. And that's what they're confessing to me. Their numbers actually might be lower at any given time. So when you think about those numbers, 50 to 80%, that means that they're adding a lot more complexity and cost as they run their day-to-day operations, especially with physical networks. And as they move to NFV, as we know, they will need to be even better accurate to be able to run things more efficiently as time goes on. So that's kind of a very high level of the OSS automation and orchestration offering that we have from our company. Let's just take a look really briefly again. This is all high level. Kai and I are available in the future to be able to have meetings to do deep dives on our product and our offering, and especially how it pertains to this presentation. But let's just take a look at a very high level of dynamic inventory and active topology. If we drill into a little more in dynamic inventory for physical networks, we are able to provide operations with an up-to-date service, IP, network element, and even wireline and wireless inventory and capacity. If you look on the right-hand side of the screen as we go to virtual networks, we'll also be able to provide VNF catalogs, license management, VNFI resources, inventory, and capacity. And finally, on the right-hand side, something that we feel is really important, and I'm sure a lot of folks on the call deal with this on a day-to-day basis. Another technology that we've been working on is having this dynamic inventory kind of feed some big data analytic engines. One for root cause analysis, which actually learns over time to give predictive analytics. One for resource optimization analytics. These two engines, just think about it, give the CSP and OpEx a very big advantage by being able to predict resource requirements in advance. And another important subject that we've all been talking about, it also leads the way for closed-loop automation in the future. And like I was saying, if you want to get more information or have more technical demonstrations or technical town meetings, Kai and I have been doing that in both our regions in North America and in Europe. We'd love to be able to talk with you, or you can email us privately to be able to get the conversation going forward. So based on that, I'm going to turn the conversation over to Kai. Kai's going to really do a deep dive into the transition from physical networks to virtual networks. Kai, I'll let you take it from here.
Yeah, thanks a lot, Bruce, and also thanks a lot, Renee. And thanks a lot, Bruce, for this fantastic intro to our topic today on the transition from physical networks to virtual networks. Just first of all, as an introduction, my name is Kai Bechtold. I'm the Vice President Sales for the DACH region. DACH region is actually Germany, Austria, Switzerland in Europe. And as Bruce already mentioned, so we are actually positioning our OpsNGN product around those topics for the transition from a physical network to a virtual network. But we'll now actually have a bit more a closer look on what's really happening here in the industry. So we will actually focus on a couple of areas here. As you can see, first is that we will focus a bit on the clarification between the terminologies SDN and NFV. We will have a close look on the transition from the physical network functions towards the virtual functions, all the challenges coming along with that, and also obviously the resulting hybrid networks we will have for the foreseeable future. And we will finish off with some sort of a statement where we are today, where are the challenges, and what kind of possible solutions actually have to be achieved to overcome the current challenges. So as I said, before we really start, let's have a look at this relationship between SDN and NFV. And I'm sure we all have been in conversations where those terms have been used to describe the same functionality without any differentiation. And quite often, if you read white papers on some web pages, you can easily see sometimes that someone is writing SDN/NFV, which is more or less indicating that those terms are the same, that they're completely interchangeable, which they're actually not. So that's why we'd like to spend a few minutes to clarify the differentiation between those terms. I mean, in fact, NFV and SDN are completely independent, yet complementary and mutually beneficial technologies. Network functions can be virtualized and deployed without any SDN technologies, and non-virtualized functions can be controlled by SDN. The primary distinction between the two has to do with the domain which they apply. While NFV replaces proprietary hardware network elements with software running on standard servers, SDN deals with the replacement of standardized networking protocols with centralized control. So SDN promises to reduce the complexity of distributed networking control protocols with the simplicity of programming and omniscient controllers. And hence, SDN is leading to advantages like the rapid development of application software in comparison to protocol standardization and development, simplification of network maintenance due to centralized control, and the ability to swiftly deploy, relocate, and upgrade new features. Network functions virtualization is highly complementary to SDN, but is not dependent on it, as I said before, and vice versa. Network functions virtualization can be implemented without SDN being required. Although the two concepts and solutions can be combined and potentially create a value accrued. Network function virtualization goals can be achieved using non-SDN mechanisms relying on the techniques currently in use in many data centers. But approaches relying on the separation of the controller and data forwarding planes, as proposed by SDN, can actually enhance the performance, simplify the compatibility with existing deployments, and facilitate operation and maintenance procedures. So network function virtualization is able to support SDN by providing the infrastructure upon which the SDN software can run. Furthermore, network function virtualization align closely with the SDN objectives to use commodity servers and switches. Just to clarify this topic in a more graphical way, let's have a look at a very simple example. On the first picture here, it shows how a managed router service is implemented today using a physical router on the customer side, the one you can see here in the middle on the right side. If you would now apply NFV technology to the situation and you would virtualize the router function, we would end up with a picture like that, where we have now the router functionality virtualized and providing this capability to the customer side. And on the customer side, we will only have a network interface device. And that is completely without SDN. If you now want to bring SDN also into this picture, we would actually then have the following setup here, where we now the data packets are forwarded by an optimized data plane, while the routing, the control plane function is running on a virtual machine on a rack-mounted server in the central office or in the data center. So that should actually show the difference between SDN and NFV, and I think we all have seen in a lot of discussion that many people use them interchangeable, but there is a difference between them, and you have to be careful that you don't mix and match those terms. Okay, now have a look at the network virtualization, which is actually the main topic of today's webinar. I would like to start off with 3 questions. The first one is, what is network function virtualization actually all about? And what are the expectations of network function virtualization, and why is everyone looking into that? And a very important question, now that we have already looked into this technology for a couple of years, do the benefits match the expectations? So let's start with what network virtualization actually is all about. It is, in its simplest form, it is the application of virtualization coming from the IT environment down to network equipment. So it's an evolution of the virtualization techniques that have been applied to the carrier core network. It gives carriers the opportunities to use standard servers and storage, which allows them to bring their equipment costs down, and infrastructure very flexible, where they can stand up new instances very quickly to test and get new services faster. It allows to share resources, so a new service can run on top of a shared infrastructure without having its own equipment, which allows to launch and test it without additional infrastructure costs. So you can turn it up very quickly, and there is no customer demand, or the service is not as expected, you can turn it down without having a lengthy process for planning and also accompanied infrastructure costs. So what does it mean actually in real terms? So you can run data plane applications on virtual server environments. You can share underlying compute infrastructure across multiple applications, standardize the hardware on virtual machines, and optimize costs and avoid vendor lock-in, enable CSPs to innovate faster and provide differentiating services on open platforms. The key takeaway is that it is an IT-based virtualization approach applied to network functions in the carrier network, allowing them to use lower cost equipment, have more agility in the provisioning of services, and take advantage of some of the management and orchestration features designed on the IT side of the business down to the network. So the next question is, what are the expectations of virtualization or network function virtualization? I mean, first of all, Heavy Reading has issued a report which actually shows that more or less every network operator is looking into virtualization as we speak. They're obviously all at different stages. Some have already started to implement some virtualization use cases. Others have started to discuss and define strategies how to do it, and others are still in the process where they define possible use cases. But more or less every network operator we're talking to is definitely looking into the technology and is trying to understand what kind of benefits they can get out of that. So why is that the case, that every network operator is looking into that? I think we all have seen this picture I'm showing right now, where we can see that the growing data traffic in the network is generating sooner or later for the operator a revenue gap because of the cost it will generate and the limited revenue they get from that. I think, yeah, as I said, we all have seen those pictures and those graphs before. So the ultimate goal actually is to improve the cost structure, so to reduce OpEx and CapEx, to reduce the complexity in order to achieve faster time to market. And with the promise of quickly deploying virtual network functionalities and creating new services without long planning cycles and associated costs, network operators are also looking at NFV to accelerate their innovation and to build a much more agile business environment. So those were all the motivations for operators really looking to this new technology. It was driven from the cost perspective, to lower the cost, and obviously to be more agile and have the possibility to bring up services much quicker, test services quicker without long planning cycles and associated costs. So coming now to the last question I showed you earlier on, are the achieved benefits a match to the high expectations? I think we, as an industry, we really have to ask a couple of questions. Have we achieved the expected CapEx and OpEx reduction? Have we managed to reduce the time to market to deploy new network services? And has the return on investment from new services improved? Are we having greater flexibility to scale up and scale down or evolve services? And can we easily trial and deploy a new innovative service at lower risk? I mean, those are all the benefits everyone was looking for to get out of virtualization. So where are we with all those questions? So well, let's park this question for a while and have a closer look at the details of what virtualization actually means and what challenges we face, and then come back to that question later on and try to answer it, and also to see where are still gaps between the expectations and what has been achieved today, and see what kind of possible solutions there might be. So in the next section on those network function virtualizations, I would like to focus on the different stages of NFV, the onboarding issue, and actually how to manage a hybrid network. So if you look at the process of virtualizing network functions, so you start off with a physical environment, and then you actually have the virtualization process, which is actually a multi-stage process. So it isn't a single step where you start from a physical equipment and you virtualize it and then you're done. So you see on the slide that we actually talk about 4 different steps or 4 different stages. And each stage will actually drive more innovation and faster delivery of application and services. So you can actually easily say with every stage, you actually will gain benefits. And all the benefits we talked about, agility and scale up, scale down, they're actually achieved as further on in those processes, you actually move towards stage 4. But let's start with stage 1. So you can call that decouple, where the software is separated from the underlying hardware. So the goal is to enable virtualized network functions to run on a standardized open platform. And actually most if not all already, network equipment manufacturers are actively working on it if they haven't done already so. While important for the potential to reduce the complexity, I think most will pass through the stage relatively quickly. What you do in this first stage is from your, let's say, from a physical appliance, you create actually a software package to have a virtual appliance, which is still a complete package and it's just running on a standard hardware platform, and not longer on a dedicated hardware platform. Stage 2 is actually the real virtualization is starting slowly. So VNFs can now be managed by a hypervisor, reaping efficiencies through better resource utilization. And that is actually the point where most of the industry is at the moment. For data plane heavy VNFs, achieving adequate performance in a hypervisor managed virtualized network, virtualized environment, is proving to be a challenge. There is a great deal of energy being devoted to hardware and software acceleration techniques. In other words, there is a new one-to-one mapping between the software-based network functions and a virtual machine. So with all the processing power, memory, and storage the VNF needs is inside a single virtual machine, resulting in a virtual machine which is really large and stateful. So the next step in the process, step 3, is cloudify. That is where the virtualized compute, network, and storage resources are managed as an elastic pool, allowing for even more efficient alignment with application demands and automated service creation and delivery. I'm actually not aware of any CSP currently offering cloudified VNFs in a significant way at this point. Although this is where the largest and most progressive say they want to be, to really have the flexibility in the virtual network functions, to make use of the underlying hardware resources in a much more efficient way. But there is also a lot of work needed in re-architecturing the VNFs coming from step 2 to virtualize now to step 3 to cloudify. And the last stage, stage 4, is actually the ultimate stage as we can see it right now. It's a decompose or the cloud native stage. That is where the virtualized resources are distributed and the VNFs themselves are decomposed into smaller functional elements, also called the microservices. This offers a promise of even greater innovation in service creation with new combinations of microservices being created by CSPs and their customers. So you would gain actually the ultimate flexibility that you don't have to, if you have a certain virtual network function, you can actually look if you can maybe combine certain functionalities from one VNF with another one. So you can really make much better use of all the resources to achieve the efficiencies you're looking for and the agility. So stage 4, cloud native, is definitely the way to go and really has the most benefits out of your VNF strategy. But as I already said before, so stage 2 is where we are at the moment. So the benefit is definitely coming that we have a virtualized VNF. We can use any standard hardware. We can run in a virtual machine environment, so it can be controlled by a hypervisor, and we can make much better use of the underlying resources. That is already achieved. That's where most VNFs, which are deployed in proof of concepts and maybe smaller live installations, are actually at the moment. So on that point, the ultimate goal to be cloud native, there is still some way to go, but I think it's a clear path on how to get there. And I think the industry is on the right path to achieve that functionality. And depending on the requirements you have for the VNF, it might make sense to go immediately to cloudify or cloud native, or if the use case is already beneficial, then staying at this virtualized stage is also fine. So now coming to another topic in the virtualization discussion, and that is VNF onboarding. The quote here states, as a fact, it needs to be easy to onboard partner functions and automate their handling across end-to-end processes to realize the benefits. So the question is onboarding an easy task? Well, I don't think so. And most CSPs we're talking to, and you can find a lot of different reports and statistics. So CSPs have really identified VNF onboarding as one of the main stumbling blocks on the path to VNF adoption. And according to analysis Maison, they say VNF onboarding is one of the major challenges the industry must solve to ensure the long-term success of NFV. This will require a standards-based approach that automates the onboarding process and minimizes its complexity. The promise of NFV is yet to be realized because of the cost and complexity of onboarding VNFs. So the problem we have at the moment with VNFs, and you can see a couple of numbers here on the slide, that it takes between 6 to 8 weeks to onboard a single new VNF. There are not many gains if you have onboarded one VNF and you start to onboard a second one, because most vendors have different proprietary technologies and packaging mechanisms at the moment, how they actually ship their VNF and how they need to be onboarded. So definitely onboarding is one of the key challenges at the moment. So as I already said on the slide before, there is no common configuration protocol on how to onboard a VNF or a common interface, and not even are commonly agreed policies. What are the required steps? Every VNF vendor has their own proprietary way to manage their VNFs, sometimes with a specialized VNF manager. And in addition, both VNF vendors and CSPs have their own challenges in the environment. And VNF vendors have to test their VNFs against multiple virtualized infrastructure managers or even orchestrators, and possibly even VNF managers with a major interoperability testing effort. And on the other side, you have the vendor, the CSPs, who also look at their own environment and would like that the onboarding process is working depending or in line with their own internal processes and mechanisms. So it's still a huge difference between onboarding VNFs and a standardized process. The good thing is, however, that there are ongoing efforts to standardize that functionality and to standardize what is called the VNF descriptor, which is a template, as well as a packaging format. So a lot of standards bodies, such as the ETSI, IETF, OSS, Tosca, and open source communities, such as OpenNFV, Open Daylight, they play actually a critical role in defining and implementing these standards. Both vendors and CSPs, however, have to keep up with the rapid iteration in standards and open source projects to really stay up to date and see really what's happening and in which direction the whole standardization is going. So on one side, you got ETSI, and the ETSI specification is defining the rich information model in conjunction with the Tosca NFV simple profile, and that specify an NFV specific data model using Tosca language. And these specifications form the basis for many of the requirements and attributes that are being implemented by VNF vendors. There's also work done on the packaging format that includes not only the structure of the package, but all the elements that make up the package, that it's the image file, VNF descriptors, the scripts, so the pre and post processing scripts, monitoring drivers, and so on. And here again, ETSI is defining the specifications and open source communities, such as OpenNFV, working on the implementation. But until such time that there is a convergence within the standards bodies and the adoption by the industry, CSPs need to consider tools today that can actually address the disparity in formats and packaging, tools that provide the ability to translate between these different formats and packages so that CSPs can easily automate the whole onboarding process in the specific environment. with the orchestrator and virtual infrastructure manager of their choice. So in the end, a repeatable and predictable VNF onboarding process will help the CSPs. But as I already mentioned before, it's at the moment still a long way to go. There are certain tools available to make onboarding easier, but there is no widely agreed standard or process on how to onboard VNFs. So that is still an area where a lot of work needs to be done to make it really much easier and to allow a CSP really to quickly onboard a VNF, test it. If it doesn't work in the way they expected, or the service is not getting picked up by the end customers, then maybe just turn it down again and then offboard the VNFs. But with the current process, it is very time-consuming and costly. So testing is not as agile as it should be with a virtualized environment. So as I quickly summarize those three topics, on the virtualization side, I think we've seen the 4 different stages. We are on a good way. We, as on the slide defined, we are at stage 2, where the functionality is virtualized and it can be managed on a virtual machine controlled by a hypervisor. We have already gained a lot of benefits out of that step from the physical appliance. But the ultimate benefit you can get out of virtualization is if we move all the way to stage 4, where actually the virtual network functionality can be decomposed into microservices and then bundled up depending on microservices and functionality. In that way, we can actually make the most use of the underlying resources and have the agility everyone is looking for. On the onboarding, I think we just covered this topic. It's still a lengthy process. It's very complicated. It's not straightforward, and every vendor has their own scripts to onboard VNFs. And even if you onboard, just as an example, a virtual firewall from one vendor, you're not gaining a lot if you want to onboard another virtual firewall from another vendor. It's not that you can gain anything, let's say, because we onboard the same VNF function. It is so vendor specific that it's really hard at the moment to have any gains of onboarding multiple VNFs. So we really need to move on to come to a point where we have a standardized onboarding process, ideally template driven, so you can easily onboard a VNF from vendor A, and you can use the same process, the same tools for vendor B, and to achieve the agility to really onboard VNFs very quickly. So with all the virtualization, we are at the point, if you look at the current network environment, you have some functionalities virtualized, some functionalities are still physical appliances, and I'm pretty sure some of the functionalities, they will stay on the physical side for many, many years to come. It really depends on the business case, on the use case, which functionalities are going to be virtualized and at which speed. So we will be running hybrid networks definitely for the foreseeable future with a combination of physical and virtualized network functions. What that means is that we will require new OSS functionalities to be able to manage the service across physical and virtual network functions, to also be able to manage the very dynamic environment in virtualized environments compared to the less dynamic, not to say static environment on the physical side. So you need really new OSS tools to offer you the end-to-end capabilities to manage a server end-to-end from physical and virtual, and to support those fulfillment and assurance functions across all different platforms you want to have, and really be able to manage the virtual environment in the way it has to be managed, because it's very dynamic, spinning up new instances or shutting down. So you really need to understand at every point in time what does your current infrastructure look like to be able to deploy and or to fulfill a new service request. So all this functionality has to be centered around a dynamic inventory in the future, which is at any point reflecting the current state of your environment. Now, a closer look at what some call next generation OSS or LSO as it is defined by NFV, the Lifecycle Service Orchestration. So if we continue the journey of virtualization, as I said on the slide before, the operators are now exploring how to operate, how to manage hybrid virtual and physical networks, and how to manage services in a common operating model across the different network layers and domains. Also, service assurance plays a critical role in maintaining the consistency of the performance metrics for services as a virtual and physical elements of the service change over time. So the dynamic nature of NFV requires a new approach to OSS to handle this dynamic environment. ETSI also argues that full automation of the capacity management and an optimization and reconfiguration cycle should be done by orchestration and cloud management techniques with open and multi-vendor components rather than a vendor-specific management solution. So CSPs need a really complete new approach to network operations in order to enable new digital services. But the industry has yet to agree the best way to integrate physical and virtual function management, control, and orchestration to support the complete automation. And only if we achieve a high level of automation, we will achieve this agility and flexibility to deploy new services very quickly or to change services very quickly. That can only be achieved if we have a high level of automation, and we can only have a high level of automation if we have in the fulfillment process, in the assurance process, always the right information about the current network status as we want to fulfill a new service. So virtualization should actually enable a flexible operations framework. Creating this framework will be disruptive for CSPs, but it will pay off in terms of increased revenue through digital economy services, enable services while supporting existing revenue streams. So CSPs need an architecture that supports a very agile operational model by allocating network resources dynamically. As I said before, the whole NFV environment is very dynamic. You can start up new virtual instances very quickly. With the change, you can actually scale out, scale up, and you have to have a very, very accurate view of your very dynamic environment. So that is where the whole NG next generation OSS from analysis maison comes in, or the lifecycle service orchestration as it is defined by NFV, to really handle those new OSS requirements. So the general recommendations for next generation OSS or lifecycle service orchestrations are, number one, is the CSPs should understand that next generation OSS is critical to deploying commercial network virtualization and should include OSS evolution plans as part of the network virtualization initiative. That actually just means that if whoever is planning a virtualization project to start and virtualize some functionalities in the network, they also need to consider that it only makes sense if you have also a management tool in place which allows you to handle this new environment, this new hybrid environment, that you can actually manage and operate your environment, and you can actually manage the services. Number two, CSPs must move to an operations model that is supported by the dynamic inventory and automated service and network orchestration and control layers. As I already said on a couple of slides before, in this very dynamic environment, it is very important to have a very accurate inventory information at any given time. Otherwise, your automation and the high level of automation we all try to achieve will actually fail if you don't use the dynamic inventory as a source on how to fulfill services. And number three, vendors should expect significant competition for next generation OSS business and have a solid strategy for management and control of hybrid networks and expect product categories to change. Actually, what Analysis Maison is trying here to say is that there are many, many vendors out to actually play in the, let's say, traditional OSS area, where fulfillment and assurance is most of the time in different systems, and they have a static flow of how to provision a service. In this new environment, we all started, I think, where we had an orchestrator, an Etsivano-based orchestrator, but pretty soon realized we need much more than just an orchestrator for the virtualized environment. So we need a complete management layer, we need a dynamic inventory, and ideally we need to merge systems like fulfillment and assurance into a single platform to be fast enough to react quick enough for any changes in the network, and maybe have some automatic healing, automatic reroute capabilities in the virtualized environment. So let's quickly summarize the three areas and where we are with all of them. I mean, virtualization, we've seen that network function virtualization is a multi-stage process, and each stage will drive more innovation and faster delivery of applications and services. Right now, we are at the stage 2, which we call on the slides virtualization, where VNFs can now be managed by a hypervisor, reaping efficiencies through better resource utilization. And to benefit from cloud elasticity and agility, the VNF need to be cloud native. That means that we can decompose each VNF into microservices. So there's still some work to be done to come from stage 2 to stage 4. But as I said before, I think that the path is clearly defined, and it's already underway for some VNFs. On the VNF onboarding, that continues to be a difficult topic until we have an agreement on a standardization and how we can actually onboard VNFs template-based with the same tools and the same scripts. It will be a headache. So on that topic, we can definitely see there's still a lot of work which needs to be done to really achieve the standardized onboarding process. Managing hybrid networks, in the traditional model, OSS are specific to a network technology and forms a funnel through which all operations and maintenance actions flow. But this model will need to change, and the previous section highlighted 2 reasons why they need to change. One reason is that the need for an automated lifecycle management requires a new and more dynamic form of resource management. That is the dynamic inventory, ideally cutting across all VNFs. And you have the decoupling of hardware and software will result in operational model in which physical layer is managed independently from the virtualized software layer. So the current management solution can be seen as a set of vertical silos predominantly focused on network elements or groups of network elements, and that make up the service. An NFV infrastructure will be much more horizontally focused, including operations across compute and storage resources and across the end-to-end network, automated lifecycle management across all VNFs, and analytics to determine end-to-end service quality. For the future, OSS will be actually centered around the dynamic master control inventory. So on the very last slide I would like to come back to the question we parked earlier on. The question was, do the benefits match the expectations? I mean, in reality, you will get 1 out of 3 answers if you ask a network operator at the moment if they have actually reached the benefits they're expecting. Some will tell you straight away no. Others might say, well, not yet. Or if they're a bit more positive, they will say it depends. The reason for those not so positive responses are, on one side, definitely the very, very high expectations generated at the beginning of the whole virtualization discussion a couple of years ago. And I think we all remember the first reports or statistics where everyone was talking about this virtualization, you can actually achieve a 40% cost reduction, all that stuff, which we all know by now. That is not that straightforward. You really need to have a look at a specific use case, a specific business case, to understand what kind of cost reduction you might have. And if this virtualization business case actually makes sense at the right time, you're thinking about it. On the other side, the complexity we described in the last couple of slides, just mentioning the 4 stages, the onboarding, the new OSS requirements, they definitely also are also a reason why the feedback at the moment is not 100% positive. So we have to do quite a bit of work as an industry to really achieve the benefits we were all talking about a couple of years ago. So I think on the virtualization, we have a clear path ahead. We know that for the most VNFs to achieve the ultimate benefits of agility and resource usage, to move to the cloud native state. On the management tools for a hybrid network, I think we have already this the definitions of next generation OSS and lifecycle service orchestration, a good understanding of the functionalities needed to have the management capabilities we need in a hybrid environment and to be in a very dynamic virtual environment. So we have an understanding that a centralized dynamic inventory is needed, and fulfillment and assurance need to work tightly together to have this end-to-end service management capability. On the onboarding side, that is the area that I think most of the work has to be done to achieve a point where we can actually safely say, okay, onboarding is now straightforward and hopefully easy, and we can quickly test a new VNF without planning for months or weeks and then spending a lot of money. So this area is definitely the one which needs the most work in the next foreseeable future to really stand up that we can actually achieve the benefits everyone is looking for. With that, I would like to close the presentation. And I think we can now have a look at questions, if you have received any questions. Glenn, do you have seen any questions, or I can see them as well, I think, if I go here.
Yes, there's a few queued up. Let me read the first one, or do you see it?
I see it now, yes, yeah. As one question, as we move into hybrid networks, there are going to be many different and separate performance metrics. What are the key performance indicators or KPIs going to look like? Okay, that's a question. That's a good question. As you know, I mean, service level agreements or SLAs are contracts between a service provider and an end user that define the level of service expected by the end user from the service provider. They contractually address reliability, including service disruption, responsiveness, and other factors. And the current SLAs should cover the customer as the CSPs move to virtualization. Many orchestration vendors are building in functionalities that not only provides for a seamless transition, but metric and reporting tools that inform the CSP of relative KPIs. Remember too that SLAs outline the monitoring and reporting service level and the consequence for not meeting the service obligations. I hope that answered the question.
Okay, this is Bruce. That was great. It's actually one more question that I see from the audience. I'll read it to you. It says, what kind of changes do you see in the traditional network planning and capacity management processes due to SD-WAN and SDN and NFV? Good question. Very good question. So SD-WAN's been getting a lot of press in the last year or so.
Okay, yeah. Network planning and capacity management or planning, they are definitely very challenging topics at the moment. I would say it's one of the most difficult issues that a CSP will face. is how to allow newly introduced orchestrators in the virtualized environment to be able to assess virtual function load in a vendor-agnostic manner, meaning how to get access to all that information if you have a multi-vendor environment. So many network vendors are proposing orchestrators, and it is unknown the level of data sharing that will occur. So regarding the limit of the virtual functions among competitors. Several standard bodies and independent interoperability organizations are already addressing this issue, but right now we have the issue that not all information is shared across a multi-vendor environment. So if you have virtual network elements from vendor A, you get the most information on the virtual function load and you need for network and capacity planning if you also have an orchestrator and other tools from the same vendor. If you have a multi-vendor environment, there is still a challenge to get all the required information in the way you need it to really do some network planning and capacity planning.